Welcome to Lecture 5.2, Applications of Differential Calculus, Equations of Tangents and Normals. Recall from Lecture 3.1, the derivative is geometrically the slope of the tangent line to the function y is equal to f of x at a point p x comma y, where the function is defined. Recall also that we have established that the slope of the tangent line is equal to the derivative, hence it is equal to the limit of delta y by delta x as delta x approaches 0. Here in this lecture video, we are going to find the equation of the tangent line as well as the normal line. Here are the steps. Given the equation of a curve or a function and the point of tangency p x1 comma y1, first, differentiate each side of the equation with respect to x, then solve for the derivative. Second, substitute the coordinates x1 comma y1 to the derivative and equate it now to m sub pl, short for the slope of the tangent line. Use the point slope form from analytic geometry to obtain the equation of the tangent line. So that is y minus y1 minus the slope times the quantity x minus x1. For the normal line, we will use the same, but the slope will be the negative reciprocal, since the tangent line is perpendicular to the normal line. Suppose that we have here a tangent line, and then we will have a normal line here. Again, the slope. Again, the normal and tangent line are perpendicular to each other. Hence, they meet at 90 degrees. First example, y is equal to 3x squared minus 2x plus 9 at 2, 9. The first thing that we should do is to see whether the given point of tangency is really a point of tangency. How? We will substitute the x and y to the given equation. So 9 is equal to 3 times the quantity 2 squared minus 2 times 2 and then plus 1. So ito nga ba ay equal? 9 is equal to 12 minus 4 plus 1. Yes. Both sides are equal. Definitely 2, 9 is the point of tangency. It is an element of this function. First step, we have y prime is equal to 6x minus 2. Next is to substitute x1 comma y1, the coordinates of the point of tangency, to x and y, or to x or y. In this case, we only have x. So we will substitute 2 only. When we substitute, we will now change this to m sub pl. Take note that the slope is not equal to the derivative at specific values. So here we have 12 minus 2. The slope of the tangent line at that point is equal to 10. Since we already have the slope, we can now get the equation of the line, the equation of the tangent line. For the equation of the tangent line, we will make use of the point slope form. Okay, we have y minus 9 equals 10, the slope, times the quantity x minus 2. Distributing the 10 to x minus 2, we have y minus 9 is equal to 10x minus 20. And then transforming this to general equation will give us 10x minus y minus 11 is equal to 0. So this is the equation of the tangent line. Next is to get the equation of the normal line. For the equation of the normal line, we will use the same point slope form and also the given point, except that the slope will now be negative 1 over 10. And then times the quantity x minus 2. So since the normal and tangent lines will meet at the same point, and it is contained by the function. For example, here, the coordinates to be written there will not be changed, only the slope. Simplifying, we have 10y minus 90 is equal to negative x plus 2. Okay, the negative here will be distributed here. Simplifying further, we have x plus 10y minus 92 is equal to 0. So these are the equations of the tangents and normal lines. Here is the graph of the parabola as well as the tangent line and the normal line. This is the normal line, and then this one, the purple, is the tangent line. Example 2, x squared plus y squared plus 4x minus 2y minus 8 is equal to 0 at 1, negative 1. So we can actually get the equation of tangent and normals right away from here without graphing this first. Differentiating implicitly yields 2x plus 2yy prime plus 4 minus 2y prime is equal to 0. Since each term on the equation has 2 or even, they are all divisible by 2. So let us divide both sides of the equation by 2. So it will be easier for us. We have x plus yy prime plus 2 minus y prime is equal to 0. Isolating the terms with y prime from the terms without and also applying factoring, we have here y prime times the quantity y minus 1 is equal to negative x minus 2. Okay, y prime becomes, ilabas natin yung negative. So we have negative x plus 2 and then all over y minus 1. Okay, now we can solve for the slope. So therefore, the slope of the tangent line is equal to negative, the x is positive 1 and then plus 2 all over negative 1 minus 1. Okay, simplifying further, we have negative 3 over negative 2. We have 3 over 2. So that is the slope of the tangent line. Okay, let us now get the equation of the tangent line. We have here y minus negative 1 is equal to 3 over 2 times the quantity x minus 1. Simplifying further, we have 2y plus 2 and then 3x minus 3. So how did that happen? We distribute this and then we multiply both sides of the equation by 2. Rearranging the terms, we have 3x minus 2y and then minus 5 is equal to 0. So this is the equation of the tangent line. And then for the normal line, it's the same, y plus negative 2 over 3 times the quantity x minus 1. So we have 3y plus 6 is equal to negative 2x plus 2. Rearranging the terms, we have 2x plus 3y, and then we have plus equal to 0. So this is now the equation of the normal line. The next thing that we're going to do is to graph the circle. So this one is a circle, obviously, because we have an equal coefficient for x squared and y squared, and they are also both positive. Okay, in graphing the circle, we have here x squared plus 4x plus blank, and then plus y squared minus 2y plus blank is equal to positive 8 plus blank plus blank. Okay, in order for this to be a perfect square trinomial, the additional term would be 4, so that we can express this as x plus 2 quantity square. And then for the other one, we have 1. In case you are wondering on how to get the third term, recall from analytic geometry, this is what we call completing the square. Okay, so you just use the discriminant b squared minus 4ac is equal to 0. 0 is being used when the roots are equal or it is a perfect square trinomial. This equation of the discriminant implies that c is equal to b squared over 4a. We have plus y minus 1 quantity square is equal to 13. Okay, so since this is a circle, it implies that the right side of the equation is square root of 13 with the square in it. Okay, we have here the center of the circle. We have negative 2 comma positive 1. Okay, and then the radius is equal to square root of 13. Okay, hanapin muna natin yung negative 2 comma 1. So this is a little bit tiyagaan lang talaga. Negative 2 comma 1 is here. And then after that, para malocate natin yung ibang mga points, gamitin natin yung square root of 13. The square root of 13 is equal to the square root of 9 plus 4, which is equal to 3 squared plus 2 squared. Okay, we can count 3 units to the right, 1, 2, 3, and then 2 units above, 1, 2. So meron tayong mabubuo na right triangle dito. And yung value nito ay square root of 13. Okay? This is the center of the circle. Tapos meron tayong square root of 13 na radius. So kahit hindi na tayo gumamit ng calculator, madodrawing natin yan. Okay. Since we have here this one, we can already draw the circle. You can actually locate at least 8 points using this relationship of square root of 13 is equal to square root of 9 plus 4. Marami pang possibility. Okay, there you go. We have here tangent line at 1 comma negative 1. So it's here. So meron tayong tangent. So drawing na lang natin na ganun. Okay, we have 1, 2, 1, 2, 3. Okay, so that is the slope of the line. Okay, next, for the normal line, starting from the point of tangency, the slope is negative 2/3, so that would be falling to the right. So the run, 1, 2, 3, and then we have 2 upwards. Example 3, find the equations of the tangent and normal to the graph of y is equal to 1 plus 3 square root of x at 4, 7. Okay, let us get the values. Okay, let us create a table of values for us to graph the function. You start from 0, and then 1, 2, 3, 4. When x is equal to 0, y is equal to positive 1. When x is equal to positive 1, y is equal to 4. When 2, yung 2 at saka 3 pwede na natin i-skip. Diretso tayo kay 4. Kapag 4, 1 plus 3 times 2, 7. Okay, so ito yung ating point of tangency. So pag dinrawing natin yan, we have 0, 1, and then we have 1, 4, and then we have 4, 7. Ayan, sige, i-trace natin. So this is how it looks like. Smooth curve, half parabola. Okay, there you go. Okay, hanapin natin yung equation nila. Y prime is equal to 3 times 1 over 2 square root of x. So substituting, the slope of the tangent line will be 3 over 2 raised 3 over 2 square root of 4. So this becomes 3 times 2 times 2, 3/4. Okay, therefore the slope of the normal line in turn is negative 4 over 3. Okay. Equation of the tangent line. Y minus y1, 7 is equal to 3/4 times x minus 4. Okay, we have 4y minus 28 is equal to 3x minus 12. Rearranging the terms, we have 3x minus 4y plus 16 is equal to 0. So this is now the equation of the tangent line. For the normal line, we have y minus 7 is equal to negative 4/3 times the quantity x minus 4. Okay, we have 3y minus 21 is equal to negative 4x plus 16. Rearranging the terms, we have 4x plus 3y minus 37 is equal to 0. So these are now the answers. So let us just label this as the normal line and this one the tangent line. You have now reached the end of this discussion. You are highly encouraged to answer the following exercise.